Number 13. The flight of a rocket can be modeled by the following equation. H of t equals negative 1/2 gt squared plus initial velocity times time plus initial height, where g is 32 seconds, 32 feet slash second squared, t is time in seconds, VO is initial height, initial velocity, and HO is initial height. If the rocket is launched at 165 feet per second at a height of 4 feet, what is the maximum height of the rocket to the nearest foot? We are given the numbers to replace the variables, so you can go ahead and plug in the the numbers into the equation. 32 goes in for G, 165 goes in for initial velocity, and 4 feet goes in for initial height. Once you've got that, you can go over to your calculator, new document, graph, plug in the equation, and make sure you add a multiplication sign before 32. When you've done that, you get your graph. You're gonna have to zoom out because it is a big number, as you can see. And look for menu 6.3 and you can get your maximum value, I think it is. I'm not sure. And you should get that, which is the maximum height of the rocket. Moving on to your second problem. Yay. The flight of a ball can be modeled by the following equation. H of t equals negative 1/2 ft squared plus initial velocity times time plus initial height, where f is 16 feet slash second squared, t is time in seconds, VO is initial velocity, and HO is initial height. If the ball is thrown at 10 feet per second at a height of 4 feet, what is the maximum height of the ball to the nearest foot? Similar to your previous problem, you can plug in your numbers into the equation, graph them, go to menu 6.3 and look for your maximum height, which should be 7. Not sure if that's right, but